All right, the question here says that the stone is thrown vertically upwards with velocity 20 meter per second. So let's create a common base here where the stone is launched. Okay, so this is a stone that is launched at this point, stone A. It is launched with a speed of 20 meters per second. Okay, now they said at the same time and 30 meters above the ground. So it means that at a height of about 30 meters from the ground, he said a second stone B is left to fall. So this is stone B, and stone B is left to fall, which means stone B is dropped. Now, in physics, vertical motion precisely, when a ball drops, it's left to fall. When a body is dropped, the initial velocity of the body is zero. Okay. Now the question says here, is it after what time and at what height do they collide? Okay. So I would say let the height of collision, let's call it h. Okay. This is the height of collision. Let's call it h. So if it is colliding at this point, if from here to here is h, then how about the remaining distance from here to this point should be, okay, should be 30 subtract h. Okay. So now, if ball A covers this height h, what does it tell me? I'm trained. Now, when the body is projected upwards, we'll be using h is the equation of motion we use. H equals ut minus half gt squared. Now, why are we using subtraction here? Because the body is launched vertically upwards. Okay. So when the body is launched, we use a negative here. When the body is dropped, we use a positive. Okay. Now let's place everything that we have here. Let's place h. H is equal to u is 20, so it becomes 20t, okay, minus 1 over 2, g is 10, 10t squared. So h becomes 20t minus 5t squared. Okay, so we're going to call this equation 1. Now again, let's talk about body B that is dropped and covers this height, this distance from here to here. Okay, and when body B covers that distance, I would say that 30 minus h is equal to ut plus 1 over 2 gt squared. All right. Now, remember, I said when the body is dropped, u is 0. So this guy goes out. Remember, we are using positive. Why? Because the body is dropped. Okay. So but when the body is falling down, it is moving with gravity. So we use positive. But when in the first case for ball A, for stone A, the body was thrown against gravity. So we use a negative. Now, so we have 30 minus h is equal to half 10t squared. Okay, so we have 30 minus h is equal to 5t squared. We call this equation 2. All right. Now all we need to do is where we see 5t squared here in equation 1, where we see 5t squared in equation 1, we're going to put 30 minus h, we'll substitute 30 minus h anywhere we see 5t squared in equation 1. So if you do that, we're going to be having h is equal to 20t minus, where we see 5t squared, we're going to put 30 minus h. Okay, so what we'll have here becomes h is equal to 20t minus 30 plus h. So now these two guys can go out here. So 20t becomes equal to 30. We can divide both sides by 20 so that t becomes 1.5 seconds. So it means that we have been able to determine the time of collision as 1.5. Now to determine the height of collision, go back to equation 1, substitute t as 1.5. So we have h becomes 20 into 1.5 minus 5 1.5 t squared. Now if I multiply 20 and 1.5, I'm going to get 30. Okay, 1.5 squared gives us 2.25. Multiplied by 5 gives us 11.25. So we have 11.25 here. If we subtract, we're going to be having 18.75. Okay, so we have been able to determine that the height of collision is 18.75 and the time of collision is 1.5.